Today we're going to talk about the divisibility test for 2, 5, and 10. The first thing we need to identify is what does it mean to be divisible? Or in other words, what does it mean when a number is divisible by another number? Well, when one number is divisible by another number, it means that it can be divided evenly so that the remainder is 0. So if we take a look at a problem here, let me just bring up a problem. Since we're doing divisibility rules for 2, 5, and 10, let's make that divisor 2. And we will pick a number such as 74. And let's determine if 74 is in fact divisible by 2. Well, if we go through our steps of long division, the first step is we need to divide 7 by 2, 7 divided by 2. Well, 3 is the closest we can get. 3 times 2 is 6. Go ahead and subtract. We need to check and make sure that this number is less than our divisor to make sure we have the group number right. We do. So we'll go ahead and bring down our next number. We'll start the process over again. So 14 divided by 2. 2 goes into 14 7 times. 7 times 2 is in fact 14, so we will subtract. And we'll have a remainder of 0. So according to our rule, or our definition rather, of divisibility, or what a number means, what it means to be divisible, it means that when one number, in this case 74, can be divided by another number, in this case 2, evenly, so that the remainder is 0. So 74 can be divided by 2 evenly, and we will have a remainder of 0. So, in other words, 74 is in fact divisible by 2. Okay? So this is one way in which you can perform divisibility and see if a number is divisible by another number. But shortcuts and divisibility tests have been generated. So today our lesson is to discuss the divisibility tests for 2, 5, and 10. Essentially, using these tests and knowing these rules will allow us to determine whether one number is divisible by another number without actually having to go through the process of long division. So memorizing those tests and using your resources will allow you to make the process much shorter when identifying whether a number is divisible by another number. This becomes very important as we go on to fractions, and we're going to be using divisibility to help us determine, help us with our fractions as far as putting things in lowest terms or finding common denominators, things like that. It will really help us with that. Okay, so the first test says a number is divisible by 2 if it is an even number. So you can check to see if a number is even by simply looking at the last digit of the number. So if I look at, let's say, the number 16,974. So 16,974. According to this divisibility rule, I am simply looking at the last digit. So this last digit is 4. If a number ends in 0, 2, 4, 6, or 8, it is divisible by 2. So since this ends in 4, according to our divisibility rule, it should in fact be divisible by 2. So for the sake of proving this, we're going to go ahead and do the division here. So again, 16,974 divided by 2. Go through the same long division process of, well, we can't do 1 divided by 2 because 2 cannot go into 1. So we're going to have to start with 16 divided by 2. 2 can go into 16 8 times. So I'm going to multiply 8 times 2. And that is 16. Subtract and make sure that the answer we get, the difference is in fact smaller than our divisor. Remember, we want the difference to be smaller than the divisor, and that's a key to make sure that we're on the right track. Okay, if it's not smaller, that means that we could make this group larger. But since it's smaller, we're going to keep going. We're going to bring down the next number. And remember, when you bring down a number, you have to start over. So 9 divided by 2. Well, the closest number of groups we can get to 9 would be 4 groups. And 4 times 2 is 8. We're going to go ahead and subtract. Again, 1 is smaller than 2, so we can move on. And this process of long division is a review. We've done that before, so the kids can go back, and we did use the saying, does McDonald's serve cheeseburgers, to help us remember the steps. Right now we're going to do 17 divided by 2. 8 is the closest we're going to get. And then bring down that final number. Bring down that final number of 4. So we'll do 14 divided by 2, which is 7. 7 times 2 is 14. And we will get a remainder of 0. So again, according to the definition of divisibility or divisible, a number is divisible by another number when it divides evenly and has a remainder of 0. So this does divide evenly. As we can see, it has a remainder of 0. Therefore, 16,974 is in fact divisible by 2. Okay, and this works with any number. So just random number 1, 2, 3, 4, 5. Okay, so we're going to have 12,345. Look at that last digit. That last digit is a 5. It does not fit into our parameters of the divisibility rule of 2. So if I would go ahead and divide this, I'm going to have to extend my page here, but that's okay. If I would divide this by 2, okay, let's go ahead and do that. Again, we can't do 1 divided by 2, so we have to start with 12 divided by 2. That's going to be 6. I'm going to subtract my 12. This is smaller than the divisor, so I can bring down the next number. Start over. 3 divided by 2. 2 can go into 3 one time. 1 times 2 is 2. Bring down my next number. 14 divided by 2 is 7. And please look back at your rules or your notes on long division if you're having trouble completing this long division here. Bring down our next number. 5 divided by 2 then. 2 can go into 5 2 times. I'm going to have 1. There are no other numbers to bring down, so this will leave us with the remainder of 1. So 12,345 divided by 2 is comes with a quotient of 6,172, remainder 1. And again, let me scroll back up. Given the definition of divisibility, we are looking to have a remainder of 0. So that tells us that this is not divisible by 2. And again, rather than going through the process of long division, you could refer to the rules that have been provided for you, and ideally you memorize so that you could skip this process. Look at that last digit. See that that last digit is not 0, 2, 4, 6, or 8, and know immediately then that it is therefore not divisible by 2.